Right, welcome back to the next video in our cybersecurity series. Yeah, we are working on this topology. So, in the previous video, we were trying to do some footprinting or recon on networks. So instead of directly starting here, I just wanted to understand how we will be doing it on an external network. So we chose itsecgames.com, and we were doing some of the activities there, like pinging it. And when we did who is pinging pings and other things, and we also found out, or we were discussing about the MTU size, which is 1500 by default. It doesn't mean that you can only send 1500 bytes of data. Out of the 1500, 1472 is the data, and you have 28 bytes of additional header files, which is um, IP header and ICMP header in our case here. If you have more size, then you have to fragment it. So it could be the settings by default do not fragment it, or you can yeah, you can send it as jumbo packets as well. So here, yes, we checked it. It is the size is 1500. It's all the default settings which is there, right? So then the next thing which we can do here is go back again and we continue from where we left. So let's do a trace route on itsecgames.com. So when we trace route itsecgames.com, it goes to on some of our local routers, and then you could see how many hops it is going on. While that is going on, let's go back to our Linux. So I just wanted to show the difference between the outputs which you can get uh, from a Linux machine and a Windows machine as well. itsecgames.com. Here we go. So here, as we were also dealing. The Linux machines routing protocols, they were routing by default to 192.168.1.1, and at the moment I'm not. I literally what I did is I removed the root, I deleted the root because I wanted to access the internet. So which means now this security mission, security operating system is not part of this network. It's not part of this network. It is just connected only to the internet because I've removed the root. Okay, so in some cases, if you want to do that, if you also have set up like this a default route, which goes to 192.168.1.1 within the network, then this is one method, but this is not the best way, I would say, because I'm recording the videos and I wanted an immediate solution, so I removed it. But otherwise, what you can do is you can change the priorities of the route, and then say that only for 192.168.1.1 you can go on to um, this gateway, this route. All the other things you can use default internet route, so you can do that. That's for you to troubleshoot uh, in your network, right? So here, coming back to this point, so see, this is the difference here. In a Windows machine, you could you can trace route it, and you have trace routed for 20 hops, and finally you get into 31.3.96.40, which would be the IP address of the server, which is the web server, the vulnerable app you have, and then it passes on through different hops within that. Okay, but here you could see that it starts from the gateway, which is our gateway 10.0.2.2, and then it's all asterisk, which means it says that, uh, come on, I'm not giving it, I'm blocking it. Okay, so it could be the firewall, or it could be something else which refuses us to reply for the routes. But here you could directly get the trace route. So now, if you have routers in between, then you could see that the routers won't reply to you, or is that a mission which is active or it is not active, the ports are open in between, or some of the ports in between are closed. So all these things you can identify here, right? It is about the number of hops it is going to reach the server on its own. So uh, we can still try ping www.itsecgames.com, and you say that I'm just going on 10, which means what I am literally saying here is I am going to just extend my TTL value, just time to leave, to 10 hops, which means by the time it reaches 10 hops, it needs to reach the destination. However, it can't reach the destination because it needs to go 20 hops to reach the destination, which means the TTL is expired. When the TTL is expired, it drops a packet. That's what it happens, right? So if in case I give 21, so it can get a reply because it we are allowing the time to live for 21 packets, but then it can reach the destination within 20 packets. So you know how many hops it has to move on. Okay, especially when you're doing inside the network from a host to a server, you could see how many hops it takes, so that is there any man in the middle devices kind of things you can work around that way. So let's try here how it works. Ping. So the same way you can do 4 hops, and then itsecgames.com, and here it says that 64 bytes from 31.3.96.40, and it says that it received it. Different outputs coming from the Linux and the Windows. So that's a difference. Okay. All right. Maybe my command is wrong here. Instead of giving 4 hops. Right. Okay. So this is one way of finding out. Um, right. I'm just taking the time as well. One way of finding out some of the passive information on an infrastructure which we wanted to work on. The other thing which I wanted to tell you is uh, to look at the DNS settings, because when we are doing whois, we found out there are the name servers and things. So let's confirm that as well. Type as a itsecgames.com. So you could see that you are getting a non-authoritative answer. It says that ITSec Games, this IP address, and this is the alias of it. Why is it non-authoritative? And so what is this TTL, right? So TTL, you all know it is time to leave. If you're in the routing world, if you're in layer 3, you are sending some packets out, and if you can't find it, if you can't find your destination, imagine you don't have any limitations. It is going to go on and on and on in the internet space, which means there will be a lot of packets which doesn't know where it is going, and it will be keep on going on, which possibly will increase the traffic. So in order to overcome that problem, that is where the TTL comes into play. So a time to leave will take is a limitation to say that you can live within the network for this many hops, and once you have crossed that, you can't still round up, you can't still go and search for your destination. You have to drop, which means the traffic of unwanted packets gets stopped. right? So by default it is 255. The TTL value by default is set to 55, and in some cases you could configure it to a less number to say that, oh, you don't want to go to 255. It could be 20, it could be 30, it could be 50, it could be 60. So you secure it. You say that you are definitely not going to go more than these many hops. So this is your time to leave. If you are exceeding that, you can drop yourself down, which means if someone is adding a hop in between, if you are taking a different route, then you could possibly drop down yourself, right? So another security aspects which we can consider of, right? So that is TTL. So here if, we have seen how TTL works and how it is to understand. The same way here in DNS, you have authoritative and non-authoritative answers. Authoritative answers are the answers which you get from the actual DNS server. A non-authoritative answer is when you get an answer, a reply from a non-authoritative, from not the actual DNS server, but maybe a different DNS server. Like I know this one, I have the record of this query you are asking, and kind of thing. So here the server which gives is so a local server which gives you uh, the the answer for the query, the reply for the query. So let's say set type as its CNAME, and it is itsecgames.com, and it says that it is again non-authoritative and it is itsecgames.com. So by default, set type is its name server, itsecgames.com. And you could see that you have 54 and 53 and 54 as your name servers. They have both IPv4 and v6 IP addresses, and these are the IP addresses which you have here as well. So this is something really cool to get some more information. Let's see what our Linux mission is showing. So here it is dig for NS lookup. So dig itsecgames.com, and it gives me itsecgames. It says that it is not authoritative. It's not the authority. It gives a query and it gives an answer. So it is ITSec games, and the answer is the A record, which is 131.3.96, and the server which is giving is 53 as well. So you can also go for a short command of www.itsecgames.com, and it says that itsecgames.com is 31. Right, 31.3.9.6. So we can now see dig plus ENS 53.domaincontrol.com, and it gives 97.74. And if we go here, it is giving, right. So let's see, ping minus C, just 4 packets. I want sorry, I want to go with n. I'm just pinging name server 53.domaincontrol.com. I'm getting a reply from 97.74, ping 97.74.106.27. I'm not getting the ping here, right? I'm just keen on the time which is going on, right? So this is some of the ways which you can find out the information as well. So here in In Linux machine, dig is to help you get the DNS records, and it gives you a lot of information as well.